Welcome everyone to Running Production MySQL Databases on Amazon RDS for MySQL. This is a workshop where you can watch our demos. You will need to use your own AWS account, and the lab guide provides some instructions on how to get started setting everything up. If you need any help, please reach out using the chat function of the webinar tool. We will also post the link to the lab guide in the chat window of the webinar tool for easier access. You can just click that link directly from the chat window. Now, our objectives today are to introduce you to Amazon RDS for MySQL, the features and capabilities of the platform, and how you can leverage them to simplify the deployment, configuration, and operational workflows of running a MySQL database. So Vijay, can you tell us more about what Amazon RDS is and why is it a great place to run production MySQL workloads?
Sure, Vlad. Let me tell you about Amazon RDS. Amazon RDS is a managed relational database service with a choice of 6 popular database engines. What we mean by that is we take the database engines. Some of them are commercial database engines like SQL Server and Oracle. Some of them are open source database engines like MySQL, Postgres, and MariaDB. And we built a management layer around them to provide automation for very common tasks that a lot of DBAs or DevOps engineers that operate these databases have to otherwise do manually. What it brings to the table is ease of administration. You don't have to worry about provisioning any hardware and installing OS operating systems and installing DB softwares and building monitoring tools around those, right? So we take care of that for you in RDS using our automation process. We also provide you easy capabilities like high availability, disaster recovery, and also we will provide you with scaling features like you can scale up the compute, you can scale up the storage as well. While we provide you with highly performant databases, we also designed that these environments are very secure to meet all the potential security needs of actual production applications. That is actually about what RDS is about. So we provide you all these capabilities. With RDS, all these tasks becomes just a simple matter of checking a box or setting a flag in a configuration file. While we are thinking about databases and administering databases, right? If you have to do everything by yourself, there is a whole host of things you have to worry about. Like you need to worry about provisioning hardware and then operating systems you have to install, and then you have to do routine maintenances, and then you have to do advanced monitoring, and you have to worry about how do you patch those, and then you have to worry about providing security and compliance for those, right? We will take care of all those for you. So that you can focus on things that really bring value to your business and focus on things that matters like schema design or query construction or query optimization. So you can spend time in innovating and building new applications. You do not need to worry about managing infrastructure. So we will take care of all that undifferentiated heavy lifting for you. Because of that reason, right, a lot of customers, we have hundreds of thousands of customers using RDS. So all these customers are coming from different verticals of the business. For example, Netflix, which is an online content provider, right? And then we have Expedia from travel industry, and we have Instacart from retail industry, and then we have Liberty Mutual from insurance company, and then we have Zynga, which is a gaming industry. They're coming from different verticals of the business, and then using RDS is a platform. Right, so let's, as for today's discussion, let's look into some of the RDS MySQL customers and their use cases, right? So Mint is a free online service that help customers to manage personal finances and track bills in a single location. When they're adopting RDS MySQL, they found out that they don't need to worry about hardware acquisition or tuning databases for their IOPS performance perspective, right? So with RDS, they can quickly spin up resources, and then RDS also help them to convert their capital expense to variable expense so that they reduce their cost by 25%. And another customer is Flipboard. They are world's first social magazine company. What they like about RDS is the management layer which comes with RDS. So they don't need to administer databases. They don't need to worry about minor version upgrades or backups or easy restore facilities, what they like, most of them, right? So they could focus on most of the innovation which comes out of RDS. That's what they loved it in RDS. Castle is one of the cloud-based social learning platform that allows students to connect with their other students as well as experts and professionals from the academics, right? So what they like about RDS is the flexibility and the reliability, and mostly what they enjoyed is elasticity, which provides the RDS. So they don't need to guess the capacity on the day one. So they know that they can scale up and down of the resources as they need them. So that's what some of the customers loved about RDS MySQL.
Okay, this is really interesting. It sounds like it will help customers reduce a lot of tedious work managing databases. So if I were a customer with existing MySQL databases in a data center, how can I run MySQL in AWS?
Oh, that's a very good question, Vlad. To run MySQL in AWS, you have basically two choices. One is self-managed. What it means is we will provide you a virtual machine, which is an Amazon EC2 compute, and then you can install MySQL on top of it. You can choose. After that, what you have to do is you have to maintain those MySQLs. You have to upgrade them. You have to do database backups. You have to patch them. You have to do all the maintenance around MySQL. And we also have a fully managed service, other option. There you have two flavors of MySQL. One is RDS MySQL, and the other one is Aurora MySQL. In RDS MySQL, you get all the fully managed service capabilities, and RDS MySQL uses the block storage subsystem for your databases. And we also have an Aurora MySQL, which is a relational database built for the cloud. It combines the performance and availability of the traditional databases with cost effectiveness and simplicity of the open source databases. One of the key Aurora features is which has a log structured storage subsystem, which is distributed and fault tolerant and self-healing storage, right? So that is the main difference between Aurora MySQL versus RDS MySQL. But today we are mostly talking about RDS MySQL. So when you're thinking about RDS MySQL, right? RDS MySQL comes up like the database engines are based out of MySQL community version with management layer around it. In RDS, we provide MySQL from all the way from 5.5 all the way to 8.0, and you get high availability across two availability zones. And then you have in-region and cross-region read replicas we will provide. That is built-in features. So with single click of a button, you can have a cross-region read replicas created it for you. And also RDS MySQL comes up with different instance classes where you can launch your MySQL. So while we are talking about RDS MySQL, before we dive deep into it, let's create an RDS MySQL instance, and then we will talk more in depth of each features, what it shows, right? So let me go back to. So let's start with console, and then once you log into the console, today I'm doing everything in California, US West 1 region, but if you want to create an RDS instance, right, you can create whatever the region which is you have permissions to, and then the lab guide which is provided that will valid in all the regions. So to create an RDS instance, click on Create Database. Once you click on Create Database, in the engine options, select MySQL, Once you select MySQL, as a discussed, right, it comes out of MySQL community. You get all the versions from all the way from 5.5 to 8.0. So let's choose the latest version for this demo. And then provide the instance identifier. So for this, I'm going to give workshop demo, and then master user. This is the user you have full admin permissions for this RDS workshop demo instance. So let's provide a username and password for the master user. You can use whatever the name you want. For now, I'm using master, and then password. I'm going to give once you enter the password, right, here, now you want to select an instance which we will use it for this RDS instance. Here we have three options. One is burstable instance classes, which is a T family, and we have a memory optimized instance, which is R5 family. You can have up to R5 24x large. And we have a standard class up till M5 24x large, which is 96 CPUs with 384 gigs. So for now, I'm going to choose memory optimized instance, and then I'm good with R5 large. So, and then storage. So we are creating a database instance where we need to keep our databases, right? So this is the storage. We have two options in the storage. One is general purpose, and the other one is provisioned IOPS. So general purpose is you can have from minimum 20 gigs all the way up to 64 terabytes. It's the same in the provisioned IOPS. The minimum you have is 100 GB, and then up to 64 terabytes of the storage. So I'm going to choose provisioned IOPS, and then and I'm going to give 1000 IOPS as default. Here you have another option. So until 64 terabytes, you can tell RDS to auto scale it for you. So we will increase the storage for you. And we have availability. You have two options. One is create a standby instance. For production workloads, we will recommend you to use multi-AZ. This is single click of a button. You can have a totally different environment created for you and a different availability zones. So I'm going to choose this. And then we have a virtual private cloud for the connectivity. This is VPC is nothing but it is a virtual private cloud, which is an virtual network which is available for you in your account. So I'm going to use the default, and then additional connectivity. So here you want to, whenever you're launching an RDS instance, make sure as a best practice, we don't want to open it to the world. So publicly accessible, no. If it is publicly accessible, everyone can connect over the internet. That means all the traffic coming from the internet. So I'm going to choose it no. And then VPC security settings. Security is nothing but firewalls for your databases, right? Who can connect to your RDS instance. So this is where you choose. I have already have some security groups, but you can click on create new and then provide security group. So for now, for this demo, I'm going to choose a security group which I have already created. But if you want to create, you can click on create new, and then once you create a new security group, then you have to configure the firewall. So I'm going to show you how it looks like. So, and then by default, RDS MySQL listed on 3306 port number. For authentication, you have a couple of options. Here, we need to password authentication, where you need a username and password, and then you can also do IAM authentication. So I'm going to leave that as default. In the additional configurations, I'm going to say database name, and then parameter groups are the configurations by For example, if you have your on-prem MySQL, where you have a MySQL config file where you put your parameters, right? This is the same as that. So you can create your own parameter group and then put your configurations, and then you can apply it afterwards, right? You have that. And Vlad is going to talk about this parameter groups in his session and his next session. So watch out for that. And then backups. So with RDS, I told you, we will provide you automated processes, right? You can enable backups, which automatically we take the backups for you. You can take the backups on up to 35 days. So all the way up to 35 days. For this demo, I'm just going to leave it as default. And then you can also tell us what time you want us to take these backups. So you can select a window and then you can say, this is the time I want to take the backups. So for now, I'm going to leave it as no preference. So I'm going to, RDS going to automatically choose a day and a time for me. So, and then encryption. So whenever we created the storage, whenever we selected the storage, you can tell you want that storage to be encrypted. So when you choose this, it will, your storage will be encrypted. So, and then you can bring your own keys as well for this encryption. If you have your own keys, you want to encrypt with your own keys, you can bring your own keys, and then you can see here, you can see your own keys as well. So for now, I'm going to leave it as default. And then performance insights, which is a tool which will provide you additional capabilities in the monitoring, where you can see what kind of queries are running, and then what is your query contentions, or what kind of wait types the queries are doing. Today I'm going to show you how performance insights works. For now, I'm going to enable the performance insights. Here, one thing you need to know is by default, it is 7 days. It's totally free with RDS service. And you can also have long-term retention for until 2 years. So I'm going to choose 7 days as default. And you can also encrypt the performance insights as well. So I'm going to leave that as default. And then monitoring, we have a couple of options in monitoring. This is enable enhanced monitoring, which has capability up to granularity up to 1 second. If you want to know what kind of CPU, how long it is taking, right? At that particular second, how much CPU your RDS is consuming. So by enabling until 1 second, you can see the metrics and the granularity. And then RDS, in RDS MySQL, just like your on-premise, you have slow query logs, general logs, and then error logs, right? So you can enable those logs as well. So I'm going to just choose the logs. I'm just going to leave the general logs. And then here you can see enable auto minor version update. What it means is we will automatically upgrade your RDS instance to the next minor version, which is available, right? So, and then you can tell maintenance window is the window where you can select if you do any changes to your RDS instance. For example, if you're changing from 100 gigs to 200 gigs of the storage, right? You want that to happen during your maintenance window, then you can select this is the window which is used in your maintenance. So normally everyone does it over the weekends, or depends on your application activity, you choose that too. So right now I'm going to choose no preference, so RDS is going to automatically pick the maintenance window for me. And then enable deletion protection. This is another extra security layer where no one can accidentally delete your RDS instance. So I'm just going to leave it as it is. So this is going to show me our overall estimated monthly cost. So this one has storage 27, and then high availability features, and then provision IOPS, very production workload kind of a workload. I'm choosing the provision IOPS. So, and then let's create the instance. So it's going to take a while. You can see it is creating.
All right, this looks really easy, at least much easier than me having to install my own database software and configure my own servers. I noticed you've chosen a couple of configurations. earlier in configuration options, I was hoping we can go a little bit deeper into some of those options. And specifically, I noticed you selected a specific database instance class and storage class. What are really the options, or what are the differences between those? And we can do this while the instance is provisioning.
Yeah, sure, Vlad. Can you see my presentation?
We're still seeing your console. There we go.
Okay, so as you asked, there are a couple of things I selected, right? Instance types. So I briefly showed you what are the instance types available. So there are basically 3 different instance types available in RDS. Burstable instances, which is T family. This is really, really good for workloads that are in transit in nature, like variable, dev and test type of workloads, right? They are really cost effective to operate and provide fairly wide range of database sizes, all the way from 1 CPU to 8 CPUs, and then 1 gig of RAM to 32 gigs of RAM. The key with this family is that the compute is burstable. You don't get the full capacity of the specific virtual CPU. You will get a portion of that as a baseline and ability to burst as long as you have some credits. So whenever you're not using the baseline, you accumulate the credits. Whenever you need more credits, we will use those credits from the pool of credits you have. And then we also have a T3 instance, which is unlimited mode. So as you have a baseline of this instance class, if you need more than your baseline, right? So you have to pay for those extra compute cycles, what you use in the T3 instance family. And we also have a T2 micro, which is eligible for free tier. So this is really good for if you want to play and understand how AWS services work. This is good instance class family. And then we have a memory optimized instances. The next 2 families of instance types are typically used in production use cases. They're really, really good instance that provides you with high performance network, and they're good for compute intensive database workloads, right? So they, in the memory optimized instances, which is our family, they comes from all the way 2 CPUs up till 96 vCPUs, and then 16 gigs of RAM from 768 gigs of RAM. And then we have a general purpose instances that are really memory. They're really good for a lot of aggregations, computations if you're doing. They provide a lot of CPU usage if you have. These are very good for CPU intensive workloads. And then they comes from 2 virtual CPUs up to 96 virtual CPUs. When you choose, so whenever you're creating an RDS MySQL instance, first we choose the version, and then we choose the instance types. And then next option, what we have is we need to choose the databases, right? In the storage. In this storage, we have 2 types. One is general purpose, and then other one is provisioned. General purpose, we have general purposes are SSD storage. It can auto scale up to 64 terabytes, and then you get single-digit milliseconds. The key thing with this general purpose is it has a IOPS are determined by the volume size. For example, if you so each 1 gig of GP2 will give you 3 IOPS. So if you have 100 gigs of storage, then you will get 300 IOPS. So you get minimum of 100 IOPS if you have a storage size below 33 gigs. And just like T instance class family, this has also burst in nature. So if you have a volume less than 1.3 terabytes, it has capacity to burst up to 3,000 IOPS for a certain amount of time. So baseline for these GP2s are 16,000 IOPS, and they are very deliver provision performance up to 99% of the time. And the other storage type, what we have is provision IOPS. Here, they're also SSD storage. They can scale up to 64 terabytes, and they provide single-digit millisecond latencies as well. The maximum IOPS in this storage type you get is 80,000 IOPS. And here, the difference is you don't have burst in nature. You have to choose how many number of IOPS you need while we are creating the RDS instance. So just now I created an RDS instance with 1,000 provision IOPS, right? So I choose provision IOPS. So this delivers performance up to 99.9% of the time. They are really good for production workloads.
Thank you. High availability is really important for customers running production workloads. And I noticed you checked the box when you created a database, something to that effect. What capabilities does Amazon RDS offer in terms of high availability?
So in terms of high availability, whenever I created an RDS instance, I choose a high availability checkbox, right? So before we talk about high availability, I want to just quickly talk about what is a region and what is an availability zone. So in AWS, region means which is a physical location around the world where we cluster the data centers. So we have regions like US, and we have regions in Europe, in Africa, in Asia. We have different regions. In that region, we have an availability zone. Availability zone is nothing but a cluster of data centers. So within a region, we have more than one availability zones. So one or two availability zones we have. And then each availability zone has independent power, cooling, and physical security. And all these availability zones are connected with Amazon Backbone Network, which provides ultra-low latency network, and also which provides you very high bandwidth and low latency networking and fully redundant network available. So those are regions and availability zones. Whatever the traffic flows between these availability zones are encrypted. So that is the concept of an availability zone and a region. So whenever we choose RDS instance to create a multi-AZ, whenever you click a checkbox, what we do is behind the scenes, we create a totally in a different availability zone, we create an EC2, which is DB instance standby compute, and then we create a storage. There are distant EC2 and EBS resources we create, and then what we do is we replicate the data synchronously. So there is, in case of a failover, there won't be any data loss. So we synchronously replicate the data from availability zone primary to standby. In case there is something wrong with availability zone, our automation process will detect that, and then it will initiate a failover for us. During that process, what happens is we will make the secondary availability zone as the primary, and then we will repair the first primary availability zone. Then that becomes the standby, and then your application can start connecting to the secondary availability zone, which will be your primary. So during this failover process, what really happens is, if you look at it, failover normally happens 1 to 2 minutes. Whenever our monitoring system detects the failure, normally whenever the database goes through a recovery process, right? So in case of a failover, also database will go through recovery process. During that recovery process, what we do is we update the DNS. So we do the DNS propagation, because RDS comes with an endpoint. That endpoint right now pointed to the primary. In case of failover, we have to update that DNS RDS endpoint with the new instance IP address. That's what happens during a failover, which is normally takes 1 to 2 minutes. And then we have an SLA of 99.95% of monthly uptime SLA for multi-AZ failover.
All right. I also noticed you configure some VPC controls and some security groups earlier. As you know, data security and protection is probably the most important topic for customers nowadays. How can customers achieve their desired security objectives in Amazon RDS for MySQL?
Yes, security at AWS security will be our top priority. So in RDS, we have few RDS access controls, who can access the databases and what kind of permissions we have, right? Let's talk about first one, access control at DB level. So whenever I created an RDS instance, I have created a master user that has a kind of admin kind of permissions you have. That is the highest privileged user you have. And then using that user, you can create users and then roles and privileges. So you still have schema level and object level permissions you have, so that you can create schemas, objects, or you can even create users, roles, and all the capabilities what you normally do in on-premise, right? So you have the same capability, and also you have enforced password policies as well. You can do that too in AWS. And other access control, what we have is we use an identity access management service. Using that identity access management service, DBAs and DevOps, whoever manage the databases, right, and then infrastructure, you can control permissions of who can create RDS instances, who can initiate a snapshot, who can delete the RDS instances, who can configure read replicas, who can configure high availability features, right? You have a full control about DBA and DevOps engineers who can do at the resource level permissions. Those kind of resource level permissions you can configure using Identity Access Management Service using IAM policies. And also we have network level security as well. Whenever I created an RDS instance, right, I choose a VPC, which is in a virtual private cloud network dedicated to your AWS account client. So in that, I also selected a security group. Security group controls the access that traffic in and out of the DB instance. So where you can configure from which applications can access my RDS instance. So you can, in the security groups, you can configure in and out for inbound roles and outbound roles who can connect to your RDS instance. At the same way, we also have network access control, which is an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more of your subnets. So you have all those capabilities to access controls in RDS. In addition to that, I also talked about whenever I created an RDS instance, I showed you there is an encryption you can do at the storage level, right? So what we do is whenever you choose an RDS instance, you can select encryption storage. RDS can be encrypted. While we are doing that, what we do is we use Amazon Key Management Service to encrypt your storage volumes. So that, and also I showed you can bring your own keys to encrypt that storage volume, where you go to KMS service and you upload your keys. You can use those keys when you're encrypting your storage, right? So what happens, right? You can enable encryption when you're creating an RDS instance. So you cannot enable encryption after you create the storage with unencrypted, right? So you have to decide, you have to plan if you want your application requires this RDS instance to be encrypted, then whenever you're creating an RDS instance, choose that instance as encrypted. And another advantage of encrypted storage is, so you have encrypted an RDS instance, now you're taking a snapshot. Those snapshots are also encrypted. Using that snapshots, if you're trying to create a new RDS instance, those newly created RDS instances will be automatically encrypted as well. And also we have encryption at rest in transit now, right? So whenever you create an RDS instance, the RDS instance will create an SSL certificate available. That SSL certificate will guard against any spoofing attacks. And also you can you can configure SSL options from your application if you want to encrypt any data coming from application to your storage subsystem, right? So you can configure SSL options. Whenever you use these SSL options, all the data is encrypted in transit as well. For that, in MySQL, you have to create a user with SSL option, and then whenever you're connecting using that SSL, you need to specify SSL mode, and then you connect to RDS instance. All the traffic in between will be encrypted for you. In addition to that, we have RDS is integrated with tightly integrated with other AWS services like IAM, and we also have a secrets manager. So you can also do IAM authentication. In MySQL, authentication is managed externally using IAM, right? So, and in this also, whenever you use an IAM authentication, you will need a DB user specific to that IAM user. So you create a DB user without a password, and then using IAM authentication, whenever you do IAM authentication, we have programmatically, we generate a token using the token as a password for your IAM authentication. So you have IAM authentication available. Our public documentation is, you have that step-by-step steps how to use IAM authentication. And also we have a secrets manager. Some of the applications has requirements that they need to rotate their passwords, right? So you can leverage secrets manager where you can keep your master user and password in the secrets manager, and then using a simple API call or CLI call, right? You can access you can call the secrets manager and then get the credentials from the secrets manager, and then you can connect to your RDS instance. So this is tightly integrated with RDS MySQL and Aurora MySQL as well. And then this is really good for if you have an auditing requirement where you have to rotate your passwords, right? If you have hundreds of users, thousands of users, rotating those passwords are really hard. So if you have Secrets Manager, you can tell Secrets Manager to automatically rotate the passwords for you as well.
This looks really comprehensive. Now, one of the main benefits of running databases in the cloud is the flexibility to only use the resources your workload needs and when it needs them. How can I scale my database in Amazon RDS if my needs change over time?
Right. So for that, we have what we have is DB instance classes we launch, and then storage type we launch, right? So you can scale both of them. Before you scale both of them, there are some of the factors which determine what you need to scale, right? So compute and memory and then network are controlled by instance classes, right? So if you have to increase the instance class, you need to determine what is my driving factor to increase an instance class. For example, if you're launching a new product or if you're launching a new game, right? So you do know that you're going to have a lot of activity coming to your instance. In those scenarios, you have to monitor compute and memory and then network so that you will get a baseline, and then you see if the baseline is good enough for you for your new product you're launching. If it is not good enough, then you can launch RDS instance class. And also storage is, you can also, if you choose like storage type is like GP2, right? So the performance input-output operations depends on size of the storage type, the storage size what you use, right? So if you are using GP2, then you may need to increase the storage size so that you can get number of IOPS. You can get more number of IOPS for your application. So once you have all these, right, so it is simple to scale. It is simple. Modify the RDS instance, and then you can scale your compute. But changing a compute is not an online operation, so it's an offline operation. There will be a downtime, so you need to make sure you configure. You may want to do that during your maintenance window or when there is no activity from your application. But increasing storage is an online operation, so you can increase up to 64 terabytes. So there is no downtime when you're increasing the storage sizes or modifying number of IOPS if you're using provisioned IOPS storage, right? And also you can scale down your instance classes. So there are some customers, they use this feature. For example, you have dev and test environments, right? And then you have activity from Monday to Friday. And then Saturday, Sunday, you don't have much activity. Then you can simply create a small job, and then where you can initiate a CLI command using the job, and then you can scale down your compute. And then on Monday morning, you can initiate the job again where you can scale up your storage types. So during Saturday and Sunday, you don't need to pay extra for your compute. So this is the one thing I was referring. Castle is one of our customers. They love this elasticity part of the RDS, and then they use this. That's why they can save some money during the weekends or when there is no activity. So you can predict using that. When you're thinking about scaling options, right? So for example, you have launched a new game, and then you do know that there are different countries you're launching, and then there will be a lot of activity you have, and then you do know that there will be a lot of reads happening. So for reads, what we have is we have a read replica. So with a single click of a button, you can create a read replica. You can create a read replica in region, or you can create a read replica in cross region as well. You can have up to 5 read replicas. So whenever you create a read replica, or in region, or wherever you're close to your customers are, right? So you can from your application, you can direct traffic to those read replicas, so that you can decrease the amount of workload which is coming to your primary instance. So whenever you do create a read replica, this is an asynchronous process, so there will be a replication lag. So you may want to monitor some of the CloudWatch metrics, what we provide you to look into the replication lag. So, and also you can promote the read replica. Whenever you promote the read replica, it will become the independent RDS instance. So I have seen some of the customers using read replica for DR purposes, and another use case would be if you want to test a upgrade, right? If you want to upgrade from 5.6 RDS 5.SQL, MySQL 5.6 to 5.7, simply they create a read replica, and then they upgrade the read replica, and then they quickly test the read replica. If everything works, then they will promote the read replica. So you can use read replicas in different ways as well. One is to scale your reads, testing for high availability, disaster recovery, and then you can also test for patching, upgrades, all those things. So let me show you how to create a read replica in RDS MySQL. I hope my instance is available, so let's check. Yeah, this is in available state. So choose the RDS instance, the one we created, and in the actions, all we need to do is click on create read replica. When you click on read replica, by default it will give you the storage instance class, whatever is there, but you can change the instance class as well. It depends on your read activity. If you think you have a lot of reads coming, then you can create your read replica with a bigger instance class as well. And you can also keep your read replica in high availability as well. So your read replica will have a multi-AZ or configured as well. And you have storage types available. I'm just going to leave it as it is. And then here you can determine in the network and security, you can tell in which region you want your read replica to be. So in region or cross region. So this is where you specify in which region we need the read replica. For now, I'm going to leave it as it is. And then subnet group, I'm going to leave it as it is. And then availability zone. If you have a primary, if you're trying to create within the region, you also can choose in which availability zone you can create your read replica. If your master is in 1A, you can choose 1B too. So, and then if you want it publicly accessible or not, you can choose that. And if you have a different security group, if you have different permissions, you may want to give it to your read replicas. You can do that too. You can create a security group and then assign that here. So I said whenever you encrypted the storage, whatever comes out of that storage is also encrypted, right? So here is the example. So my master of my original RDS instance is encrypted, so I cannot create an unencrypted read replica, so it will be encrypted. And then in the settings, read replica source, and then let's say demo read replica. And then port is by default 3306. And then you can enable IAM authentication. That's what I was referring to before. If you want to do IAM authentication, you can enable IAM authentication so that you can use IAM service to generate the token and connect to your RDS instance. And then you can enable monitoring as well. And then you can enable logging as well for your read replicas. If you want to see slow queries which are running on your read replica, you just need to enable slow queries and then configure your parameters. So right now I'm going to just leave it as it is by default, and then you can have performance insights as well, and then you can set auto minor version upgrade or not for the read replica as well. So let me create a read replica. Refresh and then see, yes, read replica is getting created, and then it is in creation state.
Thank you, Vijay, for the example. I think we can probably discuss some more topics while this is launching. Now, one thing I was going to ask, DBAs and system administrators spend a lot of time worrying about backups, making sure they're being taken as intended, they can be restored correctly, they don't disrupt ongoing workloads, and so on. How does Amazon RDS solve these problems?
Right, in RDS, let me share I'm trying to share. Okay. So in the RDS, we have two types of backups. You can take automated backups, which has retention period of 35 days. And then these are daily snapshots. It will happen during the backup window, right? So if your RDS instance is in a multi-AZ, right? Most of the production applications are multi-AZ. Then you have a multi-AZ configuration, right? What we do is we use the standby instance to take daily snapshots. And then on the primary instance, what we do is every 5 minutes we take the transaction logs so that we can provide you point-in-time restores if you have, right? If you want to go back in time, you can do that too. And then another option, what we have is manual backups. You can take snapshots whenever you want. So you can simply issue an API call, CLI command, you can create the snapshots. The difference between both of them is we do not delete your manual snapshots at all. Whenever you delete in an RDS instance, we automatically delete automated backups, but we never delete your manual backups. So you can keep it until you delete it manually. So these are the two options available for you. So, and whenever you restore a snapshot, what we do is restore from a snapshot, whenever we restore it, we totally create a new instance from that snapshot. So what it means is we do not restore it on the original instance. We totally create a new instance. So for example, you have some requirements where um, you want to copy the snapshots to one region to other region, right? For example, or one account to other account. For example, you have a dev account, you have a production account. You may want to restore your production copy data in dev account. So you can also share your snapshots to different accounts where you can restore them into the different accounts as well. You have that capability as well. And then all these snapshots are stored in S3, so you have 11.9's durability. So, and whenever you do, you can also have a capability to do point-in-time restores I was referring about, right? So because we take full backups on the standby and then we take transaction log backups every 5 minutes, right? So you have latest restorable time up to 5 minutes. So whenever you do create a point-in-time restore, we do not do it on the original instance. In this scenario also, we create totally new instance. So for example, if someone deleted a table in your production instance, right? If you want to go back in time and get that table, so you can do that. So you have to create, it will create a new instance when you do point-in-time restore as well. And if you have any errors in your application, if you want to troubleshoot, you know that there is a point where you have logical corruptions happen in your database. If you want to go back in time, you can do that to simply create a point-in-time restore, and then you can restore it. So there is a demo I kept for point-in-time restore. I want to show you how point-in-time restore works. Let me go back to my demo. So looks like this is still in, yeah, primary read replica is still creating, and this we have, it is available. As we just created right now, let me use another RDS instance where I have enough data and backups. So I'm going to use MySQL demo for point-in-time restore, but it will be the same process whenever we create a point-in-time restore. So we choose the RDS instance, MySQL demo, and then in the actions, you have a point-in-time restore option. It is just as simple as it, like just click the simple button, so it will launch totally a new DB instance. Here you have option point-in-time restore, so I can go till 350. So the last transaction log probably happened at 350, so I can go back in until 350. Also, you have an option where you can select if you want to go back in time, like Friday, you can choose that too, and then you can specify times. So this time totally depends on number of days you enable the snapshots. For example, you have 35-day snapshots, right? If you enable 35-day snapshots, then you can go back in time until 35 days. If you enable only 7 days, then you can go back in time only 7 days. So make sure your requirements, what your requirements are, what is your design plan, so that you can do the point-in-time restores. So for now, I'm just gonna sell it 2 days back. Just leave it as it is, and then engine, I'm gonna leave as it is. If I want, I can create multi-AZ. For now, I'm gonna just say I don't need my PITR instance as a multi-AZ, and then I click here, MySQL demo. This is PITR instance, and you can choose which VPC you want as well, and then publicly accessible, and then security group for your PITR. If you want to have a different security group you want to use, you can use that too. And then you can use IAM authentication, just same like what we did for creating read replica, right? You have same capabilities here too. And then auto miner version, if the PITR will use this configuration as well. So for now, I'm just going to leave it as it is as default and then launch DB instance, because the backup retention is set to 3 days. You see, that's exactly what I was referring. So I was trying to go back in time, but my backup retention period is only set to 3 days. So I cannot go back in time. So let me go back and change that to till yesterday, 12. So this is a good example to see. So launch DB instance. So my PITR, point in time restore, it is totally created a new instance. So while this is happening, right, any activity you have on your production instance, you won't be having any performance impacts while you're creating a read replica, while you're creating PITR, while snapshots is happening, you won't see any performance impacts.
You mentioned monitoring earlier. What are the capabilities that Amazon RDS provides out of the box for MySQL customers?
The monitoring point of view, RDS provides quite a lot of tools. Let me walk you through some of the monitoring capabilities. What we have Amazon CloudWatch metrics, where you can monitor your CPU, storage, and memory latencies like throughput latencies, and then you would see read-write latencies, through IOPS, number of IOPS, replication lags. All these are general CloudWatch metrics you have available. The CloudWatch metrics are, we collect every 1 minute. So you might see a granularity is 1 minute there. But we also have an enhanced monitoring where you can enable enhanced monitoring, where you have up to 1 second granularity, and you also have a lot of other metrics available. For example, CPU point of view, you have number of tasks running, and what are the number of tasks are sleeping. All these additional metrics available for you in the enhanced monitoring. So I have seen a lot of customers enabling this during when they're troubleshooting a particular issue. For example, you want to decide you want to scale up your storage, right? Or scale up your compute. You want to know what is the amount of baseline you're using. So when you enable enhanced monitoring, it will show you at that particular second what is your activity. So it depends on that. You can decide if you want to scale up your instance class, scale down your instance class, or you need more IOPS or anything like that, right? So these are the tools available for you, monitoring tools available for you. And also as a DBA, if you want to know when there is CPU is more than 80%, for example, right? So you can set up CloudWatch alarms for your CloudWatch metrics, where you set up an alarm, then you will get an email, or you can set in a text for your mobile, right? You have all those capabilities. CloudWatch alarms also available in CloudWatch service. And also, when I was creating an RDS instance, I showed you have general logs, just like the MySQL you have, right? You have general logs, you have slow query logs, and you have audit logs, right? We provide all these logs, and then what you can do is with a single checkbox, you can push all these logs to CloudWatch, where you can do some analytical kind of work. You can do some of the reporting on these logs as well. So you have that capability as well. So you can, if you want to keep your logs for long-term retention, right, you can push them to CloudWatch as well. Mostly, one of the important monitoring metrics we have is also performance metrics. So these are all the metrics. What you have is currently what's happening, and then what is your how much is CPU, how much is your latency, right? But you want to know what kind of queries are causing these kind of latencies or these kind of performance impact, right, for your applications, right? That's why we have metrics for performance insights we have. So using performance insights, right, what you can do is you can identify some of the source bottleneck issues like top queries which are causing high CPU, or you can slice your queries by looking into number of weights. What are these queries are waiting on, and which user is sending these kind of queries, and what kind of wait events I have, right? You have all this, and also you can drill down into that particular query and then see what is the actual text of that query. So this is basically a free tool for 7 days. So that you can leverage this tool, and then you can if you want, you can save up to 2 years. Whenever I was creating an RDS instance, I showed you, right, you have up to 2 years. There might be an extra cost associated for that 2 years, but this is pretty good tool where you can see, in this example, you can see the max number of CPUs that lie. So that is what it will show you. That is your baseline of number of CPUs you have. And then you can, by looking into that, you can see I have a CPU bottleneck on this graph. And then you can also see which queries are running at the time. So you have very granular level of visibility of what kind of queries are running this. Okay, let me show you how you can generate some load, and then you can see performance metrics. So let me go back. So I'm going to use MySQL demo for this lab to show you how to generate. So I have an EC2 instance. In the instructions, I have given you the instructions how to create an EC2 instance, what are all the tools needed for the EC2 instance, right? You select that, and then I'm going to connect. Either you can use terminal or session manager. So I'm going to connect using session manager. And then I'm going to see what I'm planning to do is I'm going to so what I'm going to do is I'm going to push my username and password. I'm trying to put my RDS instance username, master username and password in the secrets manager, and then I'm querying that, and then I'm going to put that, I'm configuring that in the environment variables, and also I'm going to configure my host in the environment variable. Now I have that. Now in the lab instructions, you can see I have provided you a query which will run on this RDS instance. So before I do that, I want to make sure, probably because of this lab, I have already created a database. So I'm going to see if I have, so I'm using MyLab, so I'm going to drop it before I run that command. I'm going to clean the database so that I don't want to create the same tables using the Sysbench tool, what I'm going to run to generate the load to show you the performance insights. So I'm just going to drop that. Okay, looks like it is taking time. Okay, so yeah, I ran that before. So I'm going to create that back again so that I can freshly load the data. So let me exit. So let me clear. So now I have that. So in the instructions, you see Sysbench. So And what I'm doing is I'm creating 500 tables, and then table size is this, and then number of threads. I'm using MySQL demo, and then I'm using DB username and password, and then generating the load. So it is generating the load. While load is generating, I want to see the workload, how it looks like, and performance insights. So here, on the left panel, you have performance insights, and you select that. You have an option. So we are running the load on MySQL demo, so let's choose that. So looks like I have some load is getting generated in MySQL demo. So you have a few things. So let me show you here the first counter metrics, where you can see manage metrics, where you can see configure, or you can see number of InnoDB rows updated, inserted. So I'm going to choose 3 for now, but depends on your workload. You can choose what is the important metrics you want to monitor. You can do that too, right? So then update the graph. So you can see what. So this is showing from past 1 hour. So let's refresh this. See the last 5 minutes, what's happening. And then I was talking about you can drill down, right? So you can basically zoom in and then actually see what exactly happened at that particular time. And then here you have slice by weights. You can see slice by SQL. So in this example, let's see slice by weights. I go databases. I want to see if the load is showing anything in the console. So MySQL demo, you can see there are a number of sessions coming in. You can also go from here as well. So you can just click on this and then it will open the performance insights for us. So this is when we started the work, the query, and the number of connections are increased, number of writes are increased. You can see all that information. And then this is giving you the actual work, what exactly happening during this time. So you can see what all the logs are happening, and then you can see by SQL what kind of SQL is causing by SQL query. So I'm creating tables and I'm inserting data, all this information you can see, and then you can drill down and then you can actually get actual SQL statement, what it is executing as well from here. So you can see that information too. And you can download the SQL as well. So, and the thing I want to show here is, and also you can see which users are actually causing generating this too, right? By host, I'm the only one generating this in this case, right? That is my host, and which users are master user is using, who is generating the load as well. So you can see all this information in performance insights.
Thank you, Vijay. So I'm going to circle back to the high availability discussion we had earlier. Having a push-button solution for high availability and failure recovery automated are really compelling ways to reduce operational overhead. But how can a customer ensure that the database recovers as quickly as possible with the least amount of impact on the applications?
Yes, and that's why in RDS we have launched high available RDS proxy for high availability. It improves the high availability of your applications, right? So RDS proxy has capabilities like connection pooling, right? RDS proxy allow your application to pool and share database connections to improve their ability to scale. And it can also, your applications uh, can be more resilient to database failures as well by automatically connecting to your standby DB instance while preserving application connections as well. So it minimizes the failover times, and then your application point of view, you do not need to resubmit those connections. So it improves the failovers as well. So and RDS proxy is also end-to-end communication from the application all the way to databases. It's fully encrypted. And then whenever, if you're already using proxies, right? If you have to configure RDS proxy, then you have to create them, and then you have to maintain them, and you have to make sure proxies is also high available for you. But with RDS proxy, which is a fully managed service, we will take care of that for you. So you don't need to worry about maintaining the RDS proxy servers. So connection pooling, so from your applications RDS proxy, you create an RDS proxy that is in front of your DB instance, and you use the RDS proxy as your application connection point, and then RDS proxy will open the connections for you, depends on your DB instance configurations, what you choose. And whenever applications are uh, trying to connect, or whenever there are a lot of connections that are coming in from the applications, right? It can manage those connections. If there are any sleeping connections out there, then it will close those connections for you. And RDS proxy can also do multiplexing. So what it does is proxy can reuse the connection after each transaction in your session, right? The transaction level reuse that will be reused for your multiplexing as well. And it can also decrease the failover timings. So RDS proxy can identify the secondary standby instance, so it can eliminate the DNS propagation I showed you. When there is a failover happens, it has to go through recovery, and then RDS has to update the DNS endpoints, right? So RDS proxy, whenever we are using RDS proxy, we don't need to wait for DNS propagation to happen. RDS knows your standby instance, and then your applications can connect to your new new primary instance, right? So during this failover, right, if there are any connections coming from the application, RDS proxy can hold those connections for you. So you don't need to resubmit your requests from the application as well. So the testing what we did with RDS proxy, we have identified that the failover time can be up to 66% faster. So because by bypassing the DNS. And this is the last demo I have. So let me see if I can use the RDS instance. Let me show you in action how proxy works. So I need to stop this, our previous demo. So in the lab manual, I already provided you instructions to use the failover script, this is the script I'm going to use for proxy. So before I do that, right, I want to make sure we have a proxy created. So let me walk you through the proxy creation. It might take a while, but I'm not going to create it now, but I'm going to show you how to create a proxy. So on the left panel, I have a proxies. So I've already created my demo proxy. So let's create a proxy. Click on create proxy. And then this is for workshop proxy for a workshop instance, MySQL. I told you all the connections are encrypted, so you can choose a required transport layer security so that the communication will be encrypted. And then here, where target group, you want to tell for which instance we are planning to create this proxy. So I'm going to choose my demo PITR instance because the workshop instance, whatever we created, that is 8.0 instance. So proxy is not supported for RDS MySQL 8.0. So I'm just showing demo for this PITR instance, what we just created. And then just create proxy. So that's exactly what you need, but you may want to make sure you have the security configurations so that from your application can connect to your proxy. So you want to make sure your EC2 has security groups, and you also need to make sure your MySQL, the proxy can connect to your MySQL. So make sure you have both ways security groups are configured properly. And then another requirement for proxy is it has to be in the same VPC as your RDS instance. So make sure whenever you're creating a proxy, make sure you are in the same VPC as well. So once you do that, you click on create proxy. In our case, I have already created the proxy, so I'm just going to bail out. And then the proxy is there. I'm just going to show you. So we have a proxy endpoint. So this is the endpoint our application is going to connect. So this endpoint will points to RDS MySQL instance, MySQL demo instance. So right now, what I'm going to do is, as a testing point of view, first I'm going to connect to our MySQL demo instance, this endpoint, and then use the proxy, use the failover script. So that first we're going to use this endpoint and see how much is the failover time we see, and then we're going to use proxy endpoint, and then we're going to compare the time difference between using proxy and without proxy. So let me go back to just a second. I'm building the query here for the RDS endpoint on my notepad here. Okay. Okay, so I'm using Python script where I gave my RDS endpoint and then DB username password, which we're going to get it from in the environment variables. So it is now, while I'm running using RDS endpoint, it is connected, and then it is listening on primary instance IP is 229, it ends with 229. Now let's initiate a failover. RDS demo, actions, reboot. So let's do a reboot with failover. See. So we can see it is rebooting with failover. While it is happening, let's go and monitor our script. So it is connecting to still primary. Now it cannot connect, so it detected the failover. So as we are using endpoint, it is taking while this is happening, I want to go back and see what's happening in the instance. It's still rebooting. Status is still rebooting. let's check our, so let me stop it here. So if you see here, so when we used RDS endpoint, so the failover started and then script detected and then failover took 32 seconds. And then it can connect to our old standby. Now this is the primary, so now it is connected to new primary. So that's exactly what happened. Now let's try the same thing with proxy endpoint as our proxy endpoint. Let me grab the proxy endpoint. So I'm going to connect to this proxy endpoint using same script. So this time I'm using proxy endpoint, which I got it from our proxy. Now let's do the script. There is no proxy. Okay, so I just copy pasted wrong. Just give me a second. Yeah, so now it is listening on primary instance. Let's initiate a failover, and then we're going to see demo actions, reboot with failover. Yeah, it started rebooting. Now let's go and monitor how long our proxy endpoint would detect the failover and then try to connect. Looks like it is still trying to do a failover. Yeah, looks like it still trying today. Let me see if I reboot. Yeah, it's still rebooting. Yeah, it looks like now it detected the failover and then it's immediately connected within 20 seconds. If you see here, using proxy, let me stop this. Yeah, using proxy, we can detect the failover much faster than connecting to RDS instance. So that's all I have now. I'm glad.
Thank you, Vijay. Thank you, Vijay, for patiently answering all my questions. I'd like to thank you, everyone, for attending our workshop. It was a pleasure speaking with you today. And if you have any further questions, please reach out to us. We have a few additional workshops coming up in this series. On Wednesday, in particular, we will have another MySQL-related workshop discussing how MySQL databases can be migrated to Amazon RDS effectively. If you're interested in learning more about how to move to Amazon RDS, please register for that workshop. Thank you and have a great day.